Pascal, Math Contest 1998, Grade 9. Number 1, the value of the 1 plus 3 plus 5 over 10 plus 6 plus 2 equal to numerator is the 9, denominator is the 18. Cancel 9, numerator, that's the 1, denominator is the 2. So 1/2 is the answer. So the answer is C. Number 2, if 3 times x minus 5 equal to 3 times 18 minus 5. X is, so equation both sides divided by 3, cancel 3. X minus 5 equal to 18 minus 5. X equal to, so move the negative 5 to another side of the equation. That will be plus 5. So 18 minus 5 plus 5, that's the 18. So the answer is the D. Number 3, the pie chart shows a percentage breakdown of the 1,000 votes in the student election. How many votes did Sue receive? The total, the chart is the 100%, that's the one, minus Jim 20%, minus 20%, and then Jane 45%, minus 45%. That's the percent Sue got. Total is the 1,000. We use the percentage of the Sue times the 1,000. That's the vote the Sue received. So 1 minus 20% minus 45%. That's the 35% times 1,000. Percentage cancel 2 so 35 times 10, that's the 350. So the Sue received 350 votes. That's the answer B. The value of square of the square root 669 minus square root 25 is. So all the square, the first is the 169 minus square root of the 25. So the 169 is the 13 square, so square root, that's the 13. 25 square root, that's the 5, and then square. So 13 minus 5 is the 8, 8 square, it's the 64. The answer is A. Number 5. The value of 5 to power 6 times 5 to power 9 times 5 over 5 cubed is 5 to power 6 times 5 to power 9 times 5 over 5 cubed. The power rule is the a to power m times a to power n is the a to power m plus n. A to power m over a to power n equal to a to power m minus n. For this problem, all the base is the 5. 5 to power 6, all the numerator is the multiplication. We use the 6 plus the 9 plus the 1. And the denominator is the 5 to power 3, so we minus 3. That's the base, the 5. 6 plus the 10 minus 3, that's the 13. So the answer is C. Number 6. If x equals 3, which of the following expression is even? Let's start with the A. 9 times 3. Odd times odd is odd, so not the choice A. The B is the x cube. X is the 3. Odd number times odd number, always the odd. Answer C. 2 times x squared plus the 9. 2 times any number gives even the number. So the answer is the C. Number 7. The value of 490 minus 491 plus 492 minus 493 and plus the pattern continue. The last two number will be minus 509 plus the 510. So this problem, we go backward. We from the last two is the 1. 510 minus 509 is the 1. They all equal to 1. So after 493 is the 494. This is still the 1. Still the 1. So just leave the 490. 490, we plus how many 1? The number from 491 to 510. We use last number minus first number plus the 1. They gave us 20. So the last from 491 to 510, that's the 20 number. We pair every two number. We associated the two number. So total how many the group? We use the 20 divided by 2 equals 10. So we have the 10 ones. So plus the 10 equal to 500. So the answer is A. Number 8. The average mean of a list of 10 numbers is 0. If 72 and negative 12 are added to the list, the new average is average equal to sum of the number divided by number of number. Sum of the number equal to the average times the number of the number. Now the question told us the given is the average is the 0 of the 10 numbers, so the sum is the 0. Now they added the 72. The new average equals new sum. The old of the 10 number sum, that's the 0, plus 72 minus 12 plus negative 12, that's minus 12, over the before the number is the 10, now add 2 number. New the number of number is 12. So that's the 60 divided by 12 equals the 5. So the new average is 5. That's the choice E. Number 9. What is 1/2 of 1.2 times 10 to power 30. 1/2 of the 1.2 times 10 to power 30. We cancel 2. 0.2 cancel 2. It's the 0.6. So equal to 0.6 times 10 to the 30. We don't have the choice of this answer. Now we write in other format. The exponent law, a to power m times a to power n, gave us a to power m plus n. Now we split. I need the a to power m plus n can be the split to the product of the two power, a to power m times a to power n. This problem, we use the 0.6 times 10 to power 29 plus the 1. Now they equal to 0.6 times 10 to power 1 times 10 to power 29. 0.6 times 10, that's the 6 times 10 to power 29. So the answer is B. Number 10, if x plus y plus z equal to 25, y plus z equal to 14. So solve this equation. They ask what's the value of x. This is the equation 1. This is the equation 2. We use the equation 1 minus equation 2. X give us x. Y minus y, 0. Z minus z, 0. Equal to 25 minus 14. That's the 11. So the answer is B, number 11. The number in an unshaded square is obtained by adding the numbers connected to it from the row above. The 11 is one such number. The value of x is. So the 5 plus the 6, that's the 11. 6 plus the x goes here. 6 plus the x. And the last white square, that's the x plus the 7. Now the 11 plus the 6 plus x goes here. That's the 17 plus x. And the 6x plus the x plus 7, that's the 2x plus 13 goes here. Finally, these two boxes add together go to 60. So that's the 17 plus x plus the 2x plus 13 equal to 60. X plus x, that's the 3x. 17 plus the 13 is the 30 equals 60. So 3x equal to 60 minus 30, that's the 30. So x equal to 10. So the answer is E. Number 12, in the diagram, DA equal to CB, what is the measure of the angle DAC? Now, the given is the DA, this side line, equals CB, this side line. And now, for the triangle ABC, sum of the angles is the 180 equal to 70 plus 55 plus the angle CAB, label that as x, plus the x. Now solve the x. X equal to 180 minus 70 minus 55. That's equal to 55. Now the x equals 55. This is isosceles triangle because the x is the 55. Angle B also 55. So triangle ABC is the isosceles triangle. AC equals BC. We already labeled AD the equal to BC. Now the AD equals AC2 because all three sides AD, AC, BC are equal. That means triangle ACD is also isosceles triangle. Angle D is also the 40 degree. So sum of the triangle is the 180. So the triangle ADC angle DAC equal to 180 minus 40 times 2. That's the 100. So the answer is B. Number 13. A three-wheeled vehicle travels 100 kilometers. Two spare wheels are available. Each of the 5 wheels is used for the same distance during the trip. For how many kilometers in each wheel? So that's the three-wheel. So three-wheeled vehicle go to the 100 kilometer. If we use the three-wheel, we didn't change. That means that each wheel traveled 100. Three-wheel total together traveled the 300 kilometer. Now, they ask the use the 2 spare wheels. They all the equal same distance. Total 300 kilometer divided by the 5 wheels equal to 60. So that means each wheel traveled 60. The answer is E. Number 14. The sum of the digits of the 5-digit positive integer is 2. A 5-digit integer cannot start with 0. The number of such integer is, so 5-digit integer 1, 2, 3, 4, 5 cannot start with the 0, so we can only have the 2 choice, 1 and 2. Sum of the digit is 2, so for the first, the start with 1, we can only choose the 1 for the other 4 digits. So 4 choose 1. These 4 places choose the 1 to put the 1, or the other put the 0. If the first digit start with the 2, that's the only one choice. All the 4 place digit must put the 0 because the first digit already the 2. So 1 more the number 2, 0, 0, 0, 0. So add them together is the 5. So there are only the 5 such of numbers. That's the answer E. Number 15. 4 points are on a line segment as shown. If AB to BC is the 1, 2, 2, and BC to CD is 8 to 5. Then what's the AB to BD? So we already have the ratio here. In the first ratio, AB to BC is the 1 to 2, and the BC to CD is 8 to 5. I use the LCM, rewrite the BC. So the BC, the first ratio times 4 gave us the 8. The AB must be times 4. So now the ratio, we can write the same ratio because the BC now all equal to 8. So AB is the 4, to the BC is the 8, to CD is the 5. That's the multi-way ratio, 4 to 8 to 5, AB to BC to CD. Now they ask AB to BD. So BD equals BC plus CD. AB is the 4, BC plus CD is 8 plus 5. That's the 13. So AB to BD equal to 4 to 13. That's the answer A. Number 16. On a rectangular table 5 units long and 2 units wide, a ball is rolled from the point P at an angle of 45 degrees to PQ and bounce off SR. The ball continues to bounce off the sides at the 45 degree until it reaches S. How many bounces of the ball are required? Now, the ball starts from the P, roll to the 45 degree. This is the 45. Because the P is the 90 degree, another angle is still the 45. S is the right angle, so this angle at the bottom still the 45. That means that this is isosceles right triangle. This is the 2 by 5, the rectangle table. So this side width is the 2. That means this part still the 2. Now from this part, they go to the still the 45 degree. So this is the 45. If from the top point we do a perpendicular one, so this part, this angle, still the 45, and this one equals this one. The two sides equal. That's the isosceles right triangle. So this part is still the 2. Now 5 minus 2, this is the 1. So from this point, we roll another 45 degree. That means this part is the 45 too. So this is the 1. And from here, from the point on QR, go another 45 degree. That means the 1, 1. And then continue on, we will go another, the 45 degree. Another 45 degree. So how many bounces we can count it? So that's the first bounce, second bounce, third bounce, 4 bounce, and then 5 bounce. It's back to S. So the total is the 5 bounces. That's the answer D. Number 17. If 1998 equal to P to power S times the Q to power T times the R to power U, where P, Q, R are prime number, what is the value of the P plus Q plus R? So now we do the prime factorization of the 1998. So even number divisible by 2. 9, 2 times 9, 18, another 19, 9, 18, and another 9, that's the 18. 999 divisible by 9. 9 is the 3 square. That means the 1, 1, 1. So 1, 1, 1, still divisible by 3. That's the 3 times 3, 9, and 21, 7. So now the prime factorization of the 1998 equals 2, 2, 3, 3. That's the 3 cube times 37 equals the P to power S times Q to power T times R to power U. Now we can figure out that's the P equal to 2 and Q equal to 3 and R equal to 37. Now the P plus Q plus R equal to 2 plus 3 plus 37. That's the 42. So the answer is C. Number 18. In the diagram DEFG is a square and ABCD is rectangle. A straight line is drawn from A, path through C, and meets FG at H. The area of shaded region is. Question asked about the shaded area. So to calculate shaded area, we always can use the all area minus white part area. All area is the area of the square. That's the 1 times 2. And the square area is the 4 square. That's the all area. We minus area of the A, H, G. AG base is the 6, 2 plus the 4, but we don't know the AHG. Now we let the HG equal to X. So we notice that triangle ACD similar to the triangle AHG. That's the AA similarity. They share the angle A. Also, another angle is the right angle. So that's the AA similarity. So the similar triangle, all the sides ratio is constant. So corresponding the side AD over AG equal to CD over HG, that's the X. Now AD equals to AG, that's the 2 plus 4, that's the 6. CD is the 1 over X. And 2x cross multiplying equals 6. X equals 3. So x equals 3. The triangle area equal to 1 over 2 times base times height, and 1 over 2. Base is the 2 plus the 4. That's the 6 times height is the 3. Cancel 2 and 6, cancel 2. That's the 3. 3 times 3 equals 9. The area of the triangle AHG equals 9. The total area is the 2 plus 16 minus 9. That's the 2 plus 16, that's the 18, minus 9 equal to 9. So the 18, that's the square and the rectangle area. The 9 is the triangle AHG area. Total area minus white part area equal to 9. So the answer is D. Number 19, using only digits 1, 2, 3, 4, 5. A sequence is created as follows. A sequence is created as follows: 1, 1, 2, 2s, 3, 3s, 4, 4s, 5, 5s, 6, 1s, 7, 2s, and so on. The sequence appears like the 1, 2, 3, 4, 5. After the 5, start with the 1. That's the 1, 2, 3, 4, 5, 6, and continue the pattern. So first we got the 1. We have the 1, 1. And then the second is the 2, 2. And 3, 3. Plus the 4, 4. And plus the 5, 5. Continue on till what number? We don't know, but we know that's the last number. If it is x, add them together, that's the 100. This is arithmetic sequence. Sum equals the first number plus last number x times number of the number, that's the x, divided by 2, equal to the 100. So to solve this problem, we use the 1 plus the x times x equation both sides times 2 equals the 200. So x squared plus the x equal to 200. Now x squared close to the 200. That means the 14 squared equals 196. Very close to the 200. Now the x roughly is the 14. We have the 14. But what number? That's the 14 number there. Look at this is the every 5. It's the repeating from the 1 to 5. We use the 14 divided by 5 equal the 2 remainder 4. So after the two repeating, then they have the remainder 4. So remainder 1 is the 1. Remainder 2, that's the 2. Remainder 3, that's the 3. Remainder 4, that's the 4. So the x is the 4. So the answer is D. Number 20. Driving between two towns 110 km per hour instead of 100 km per hour save 9 minutes. The distance in kilometers between two towns is, we know that the speed equals the distance over the time. And from this one, we can get that the time equal to distance over speed. So distance between the two towns is the x. When the speed is the 100 km per hour, use the x over 100 km. That's the time. Speed is the 100. But instead of the 100, if speed is the 110, that's the time is the x over 110. They save the 9 minutes. That means the x over 100 minus x over 110 equal to the 9. But 9 is the minute. 110 and 100 are all the kilometer per hour. We convert the 9 to the hour divided by 60. Solve this equation. So first we cancel the 1, 0. And also we cancel the 3, that's the 3, that's the 2. So equation is the 100 over 10 minus 100 over 11 equal to the 3 over 2. So the left side, least common denominator is 110. So that's the 11x minus 10x equal to 3 over 2. And that means the x over 110 equal to 3 over 2. Isolate x equation both sides times 110. That's the 3 over 2 times 110. Cancel 2, that's the 5. 3 times 55, that's the 165. So the distance between the two towns is 165. The answer is C. Number 21. Q is the point of intersection of the diagonals of one face of a cube whose edges have length 2 units. The length of QR is. The length of the QR from the cube, we draw the perpendicular line to the base. And this point is the, if we label that QR, we label that P and S. And also we draw the RP. Now we have the triangle PQR. That's the, we can use the Pythagorean to find the QR square. equal to the PQ square plus PR square. And the PQ, that's the 1. Because side length is the 2, this is the 2 diagonal intersection. That's the center of the square. So from the center to each the side is the 1. So this part is the 1. What we need to find is the PR and SR, this is the R. SR is the 2. All the side length is the 2. PS, that's the P from the perpendicular, from Q perpendicular to the base. They divided the base to the 2 equal parts. So this part is the 1. SP is the 1. And the P to another side is the 1. Total together is the 2. And now we can find the PR square. PR square equals, that's the Pythagorean theorem, 2 square plus the 1 square. The triangle we use is this one. That is the right triangle, so equal to the 5. Now PR square equals 5. PQ square, that's the 1 square. So we can continue do the PQ square, that's the 1 square. PR square, that's the 5. It's the 1 plus 5, that's the 6. QR square equals 6. Take the square root. QR equal to square root 6. So that's the answer E. Number 22. A deck of 100 cards is numbered from 1 to 100. Each card has the same number printed on both sides. One side of each card is red and the other side is yellow. Barsby places all the cards right side up on the table. He first turns every card that has a number divisible by 2. Then he examines all the cards and turns over every card that has a number divisible by 3. How many cards have the right side up when Barsby is finished? So the deck of the cards 1, 2, 3, 4 continue on the 100. The one side is the red. One side is the yellow. What he first do, he turn over every card has divisible by 2. Divisible by 2, that's the odd even number. From 1 to 100 number have the 50 even number. So even number turn over right now will be the yellow and the red on another side. So now is the 50 yellow. And another side is the 50 red. That's the 2 sides of the card. All the even number will be the yellow because they turned the even. All the even number is the yellow. All the odd number are red. So all the odd red. So 50 red, all the number, 50 even number. Now He then turned the cards divisible by 3. The first he turned is divisible by 2. That's the even number. Now he turned the divisible by 3. Divisible by 3 number from the 1 to 100. That's we use the 100 divided by the 3. That's so floor number, that's the 33. So total is the 33 odd number. But in these 33 numbers, some is the even, some is the odd. Because that's all the multiple of the 3 can divisible by 3. So when the odd number times 3, like the 1 times 3, 3 times 3, and 5 times 3, they are all the odd number. But all the even times odd, always the 4 times 3, and 6 times 3. So how many odd, how many even? 33 times 3, that's the 99. That's total is the 17 numbers. So 2, 4, 6 total till the 32 times 3. So that's the 16 numbers. Number of number is the 16. 16 of the even number and 17 of the odd number. All the odd number is the 50. So 50. We turn the divisible by 3, 17 number. When we turn the odd number, right now odd number on the right. So when they turn the 17, this 17 will be the yellow. The rest will be the 33. Is still right because we didn't turn this 33. We turned the 17 multiple of the 3. 1 times 3, 3 times 3, 33 times 3. So 135 till the 33. That's the 17 numbers. And also for multiple of the 3 still has the 16 even numbers. Right now, all the even number is the yellow. We turn the 16 multiple of the 3. We turn it. Now they from the yellow to the red. Total 33 plus 16 is the 49. So the answer is E. Number 23. The numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 999, 999, 999 are multipled. How many of the digits in the final result are nice? So let's do the math. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 999, 999, 999. So we do 1, 2, 3, 4, 5, 6, 7, 8, 9 times. That's the 9, so many 9 equals 1 billion. Minus 1. Now the 1 billion minus 1, use the distributive property. The first number gave us 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 9, 0, 1, 2, 3, 1, 2, 3, 1, 2, 3, and the minus 1 times this number, still this number. That's the 1, 2, 3, 4, 5, 6, 7, 8, 9. I stack the number. we do the math. So 0 cannot minus 9, so we keep going to the from here. So break the 1 to the next digit, break to tens. So this will be the 8. Now still this will be 9, 9, 9, 9, 9, 9, 9, 9. Last one will be tens. That's the often we have to do like this. 10 minus 9. Where is the 10? We borrow from the tenth digit. Where tenth digit is 0, we break the 100 digit, and that's the 0. Continue to the front to the 9. So that's the final. Give us like this. 10 minus 9, that's the 1. 9 minus 8, 9 minus 7, 9 minus 6, 9 minus 5, 9 minus 4, 9 minus 3, 9 minus 2, 9 minus 1, and bring down the 8. Now that's the from the here. Still the front number is the same thing. 1, 2, 3, 4, 5, 6, 7, 8. So that's the product of these two numbers. This is really big number. The question they ask, how many of the digits in the final result are nice? We can see that's the no nice. That means the 0 nice. So the answer is A. Number 24. 3 rocks have a combined area of 200 meters square. By overlapping the rocks to cover a floor area of 140 meters square, the area which is covered by exactly 2 layers of rock is 24 meters square. What area of floor is covered by 3 layers of the rock? Now this problem, we draw the one diagram. That's the 1 rock, 2 rock, 3 rock. Let's we label the part. This is the A, B, C, that's the single layer. D, E, F, that's the double layer. And G, that's the 3 layer. So they told us the 3 rocks combined, the area is the 200 meter square. So that means the A plus the D plus the G plus E. That's this, the rock. And then plus B plus E plus F plus the G. That's this rock. And now we have the last rock. That's the C plus the D plus the G plus F. That's the yellow circle part. So combined area is the 200. So they equal to the 200. That's the first, the given. Now let's simplify. 200 equals A plus we have the sum, the A, single layer, we add them together, A plus the B plus C, and the double layer is the 2D plus E plus F. We have the 2D, 2E, 2F, and we have the 3G, 1, 2, 3, plus the 3G. That's the first given. Now another one is by overlapping the rocks cover a floor area of 140. What's the 140? That's they cover the total area. That's the A plus B plus C plus D plus E plus F plus the G. That's total is the 140. That's the second they given. The last given is the two covered by 2 layers of rocks is the 24 square meter. That's the 2 layers. Look at the are 2 layers. Which is the 2 layers? That's the E, F, and the D. So that means the E plus F plus D equal to 24. Now solve this equation. So E plus F plus D equals the 24. That means the here. So this part equals 24. 200 equal to A plus B plus C plus, that's the 2DEF. I separate D plus E plus F plus another D plus E plus the F, then plus the 3G. Now we use the substitution. D plus E plus F equals 24. So this one, substitute with the 24. And also, A plus B plus C plus D plus E plus F plus G. And also, they equal to 140. So this 3G, we break to the 2G and 1G. So now this all together is with the same thing with this one, from A to plus B plus C plus D plus E plus G. 200 equals, this part equals the 140. A plus B plus C plus D plus E plus F plus G. And they plus D, E, F. Substitute with the 24. And now plus the 2G. That's good. Just have the one variable. So 2G equal to this 200 minus 140 plus the 24. That's the 164. Bring these two numbers to another side, it's the negative, equal to 36. So 2G equals 36. G equal to, equation both sides divided by 2, 18. So the G, that's the, look at our graph, that's the cover by the 3 layers of the rock. So the answer is B. Number 25. One way to pack 100 by 100 square with the 10,000 circles, each of diameter 1, is to put them in 100 rows with the 100 circles in each row. If the circles are repacked so that the corners of any three tangent circles form an equilateral triangle, what is the maximum number of additional circles that can be packed? That's the one way pack the 100 by 100 square with the 10,000 circles. So that's the 100 by 100. Each row has the 100 row total, the 10,000. That's the 10,000 circles in this the way to pack. Another way, now repack in the second way, the bottom the way. So they repack. The repack will be the tangent circle. So that's this circle is the equilateral triangle. So the each side length is the 2 radius. So that's the diameter, that's the one. The height from the here to here, we will try to find this height. If this is the h, and because the two rows right now, the two rows will the height here, look at. So this is the bottom from the center to the bottom, that's the radius. The diameter is 1, this is the 1/2. And now we need to find, first is the h and another is here. What's this, this part? Now we do another, the equilateral triangle. We will connect another equilateral triangle. We will see that this equilateral triangle, the height is the same as the bottom one. If we find this height, we will get this height too. This height must minus this. We use the height minus this part. This part, that's the radius, minus this radius gave us the height, this black one, this one. Total is the one height minus radius above the blue line to the center. That's the radius. So this black part equals the height, the equilateral triangle height minus 1/2. Now the total, this part, that's the 1/2 plus right part. Right part is the height plus the top, the black, the height, that's the height minus 1/2. So the height of the equilateral triangle minus radius. So that's the total height of the bottom. Now we'll try to get the height. So we use the formula. The equilateral triangle area equals √3/4 times side length square. √3/4 times 1 square. Side length is the 1. It's just equal to √3/4. And we use another, the triangle, the area equals 1/2 times base times height. For this one, the base, that's the 2, the radius is the 1, and the height is the h. So they also equal to, that means the area also equal to 1/2 times h. Now we come to here, we go to the here. So the h equal to both sides times the 2. H equal to √3/2. Now we can plug in h equals square root 3/2. Plug in this, the height. Now we get 1/2 plus √3/2 plus √3/2 minus 1/2. So 1/2 minus 1/2, we cancel that. So √3/2 plus √3/2, that's the √3. √3 is roughly 1.732. So that's the two height right now after we repack. But at the beginning, what's the one row is the 1 unit, because that's the diameter. The second will be another 1 unit. So total 100 by 100 will be the 100 row and 100 column. Total is the 10,000. What's now? How many we packed more? We use still the total height is the 100 unit. So we use the 100 divided by √3, 1.732. Roughly equal to, that's the 57.736 something, 6 or 7. 57, that means that there are 57 double row. So we will use the 57 times √3, 1.732 equal to 98 and 724. So unit, that means the double row is the height 98. The total is the 100 unit. 100 unit minus 98, 724, 57 double row. So 57. The first row is the 100, is just the normal. That's the diameter is the 1. We have the 100 circle. But the second row, look at, we are short of the half of the beginning. And also the half on the end. So the total will be the 99 on this row. So double row total is the 199 circles total. So 57 times 199 equal to 11343. But we leave the 1.27 unit on the top. We can put one more rows. So one more row, that will be another 100. So plus another 100. That total is 11443. That's the repack. But at the beginning, it can pack 10,000 circle. We minus 10,000 circle gave us 143 circles more. So answer is the D, 1,443 more circles.